Good afternoon, everybody. We're going to get started now. Thanks for attending. Thanks for supporting the research paper track here at the SSAC. We're in our third year of existence now, and we're really excited with the quality of the papers this year. We've had some great submissions, and I'm happy to present our two finalists for the competition here this afternoon. Before I do that, I just want to take a quick moment to thank a couple of people. The first is the student team that helped organize the logistics and reading through over 100 paper submissions that we received. Also, the academic advisors that helped us check with all of the advanced analytics and make sure that methodologies were rigorous in the publishing of these papers. Finally, I need to thank the people keeping the lights on. That's our sponsor, Live Analytics Ticketmaster Company. Also, ESPN has been a huge supporter, and don't forget to go online and vote for your favorite paper on ESPN.com. Okay, now on to the papers. The first person that will be speaking is Kirk Goldsberry. Kirk is a visiting scholar at the other school over there in Cambridge, Harvard University, at the University Center for Geographic Analysis. He received a PhD from University of California, Santa Barbara. Kirk's research focused on spatial analysis and visual analytics. He has found a new way to combine his academic research interests with his love of basketball, and today he'll share that with us through his paper analyzing players' shooting ability by using visual and spatial analytics. Kirk.
Thanks everybody for coming. I understand there's another talk going on somewhere with Bill James, so thank you for being here. Today I'm going to talk about Courtvision, and I'd like to start with a quick question, which is simple. Who leads the NBA currently in field goal percentage? Does anybody know? Tyson Chandler. Very good. Tough crowd, huh? All right, we'll see. We'll see about this. Who leads the NBA field goal percentage at this location? Nope. I'll keep going until somebody gets it. Could be wrong. Tyson Chandler. Tyson Chandler. No. Leandro Barbosa. Huh? I would not have expected that. One more. What about this place here? The right elbow. Players left. Dirk leads in attempts. There is a Hollinger in the house. Huh? Amari Stoudemire with a surprising 1.23 points per attempt from that location. So space matters. That's the point of these slides. So this is my thesis. Basketball is a spatial sport. Basketball expertise requires spatial reasoning. Conventional analytics often fail to facilitate spatial understanding about clearly spatial performance phenomena. And I'm not here to pick on conventional metrics. I'm here to suggest that many of them fail to detect these spatial effects in performance. Partly because they reduce court space to this monolithic thing and ignore the spatial character of performance. They're looking at Tyson Chandler as really great at field goal percentage from the whole court, when in reality we all know that's not true. As a result of that, the focus on sort of aspatial or non-spatial analytics, key NBA performance phenomena have remained undetected for years. However, with new kinds of data sets, mostly spatial data sets, there's a huge opportunity for us to expose and reveal these spatial elements of NBA performance with unprecedented clarity and precision, and help us explain why certain players do certain things and how they're doing them. So that's me. I got an introduction. Before I go too far, I would like to offer my sincerest appreciation to the Sloan Conference. The opportunity to present here is really cool for me, and particularly the research paper team who spent long hours looking at a lot of papers for us to be here today. So thank you. For the rest of my time, I'm going to present the paper I submitted to the Sloan Conference and talk to you about some of the future of what I see in Courtvision and these spatial and visual analytics for the NBA. And then hopefully there'll be time for a Q&A at the end of that. So as I said, basketball is a spatial game. It's a spatial sport. The structure and dynamics of the court space influence every minute of every second or every possession of every game. They determine the outcome in many ways of every possession. Why aren't we accounting for these in our current analytic approaches? The overarching goal of my project, which is an ongoing project, the paper here is one project I did, is to create a new ensemble of spatial and visual analytics for the NBA that capture the spatial effects of performance and quantify spatial elements of performance and present them in a way, in the previous session, somebody was talking about this, but present them in a way that is very efficient and digestible and translatable to audience of all kinds, not just statisticians. And it's my firm belief that visuals and graphics, particularly maps, offer us a huge solution for communicating, integrating from top to bottom through the analytics process that numbers oftentimes are unable to do. So how does it work? Let's go through my basic framework. We start with this blank canvas. We've all seen something that looks like that before. And then for this paper, I looked at a subset of the what I call the scoring area, which is a 1,300 square foot area where 98% of NBA field goals occur. The area where offensive possessions occur and where players are shooting. And then I plotted 700,000 shots for the last 4 or 5 years, and I started to evaluate spatial tendencies, not only league-wide tendencies, but also individual team tendencies. And I was like, wow, this is pretty cool, you know, we can start, this is just a messy plot right here. Each one of these red dots actually represents 50 shots. It's what we call in the cartography world a dot density map. Shows the spatial distribution of a function, in this case shooting. But you could imagine in your mind's eye, instead of shooting, this is rebounds or steals or Jeremy Lin's first 200 field goal attempts, something like. I have to mention Jeremy Lin contractually since I'm here at the Sloan Conference today. So after this, we do a lot of analysis and answer spatial questions, but we don't stop there. And I think that one thing that separates my project a little bit from others is I'm really concerned with producing graphics that are understandable by people, all right? I'm not communicating with robots, I'm communicating with human beings. So we do analysis at the spatial level, and then we communicate our results via graphics. So there are two real components to my work, and one is spatial analysis, which is originally called spatial data analysis. It's just an extension of conventional statistics designed to help analysts describe spatiality, how something sort of appears in space, find clusters, find patterns, find spatial correlations, and so forth. So you can think of it as sort of a spatial extension of conventional statistics. Very common in quantitative geography, public health, military science, and all kinds of other domain areas. Strategic spatial domain areas, I might add. Visual analytics is not a word I made up. This is not a buzzword. This is an academic endeavor itself. It's concerned with creating visual interfaces to complex data sets where people can browse through data and answer questions and explore the data and not necessarily have a pure question in mind, but can explore data. And this is something that's really important as the NBA enters what I call its big data era with optical data. We need tools that allow people to see a lot of information in a short amount of time, to reach defensible strategic judgment in a very short amount of time. And visual analytics are really good at sort of providing this graphical interface to a giant, massive data set. And at their best, they help us find something out in a really short amount of time that's profound and effective and strategic. And that can apply to basketball. Again, huge applications in defense, huge applications in climate research, huge applications in public health. Since I love basketball, I thought, why not sort of look at how these things can help us determine things about basketball we didn't know. So in the paper, I present a case study, who's the best shooter in the NBA? And this is David Aldridge, one of my favorite NBA reporters. But great quote when asked this exact question. He said, "Everyone has their favorite spots on the court, but it seems like Ray Allen is more comfortable in more places than anyone I've seen." What I like about this quote is that's a reasonable conclusion, and there's a clear spatial criterion used in his answer that is not captured by conventional approaches to understanding shooting in the NBA. And that is more comfortable in more places. More comfortable in more places. Field goal percentage does not give you that. Even the enhanced field goal percentage or effective field goal percentage does not give you that same kind of answer. So my question is, who is the most comfortable in the most places? In other words, who is the most effective from the most spots on the court? That's the question I sought to answer. And I kind of think of this as shooting range, which is an ambiguous basketball term, I realize, so bear with me if you disagree with how I'm using shooting range. Don't worry, I kind of do too. But in this sense, I'm going to define it as the ability to shoot effectively from diverse court locations, not how far away I can shoot, which is an alternative, perfectly viable definition of shooting range, but the diversity of my court location abilities. And how do I quantify that? I quantify that with something I call range percentage, which is essentially the percentage of that gridded area I showed earlier where a player shoots effectively. Now, what is effectively? We have to set a threshold for that. And what I did in this paper is say 1 point per attempt. 1 point per attempt. And I'm not in love with that threshold, but I thought it was the best first chance to go. The 1 point per attempt. So 50% from 2, 33.3% from 3. Okay, simple. Who achieves that highest range percentage is essentially the question I'm answering. And what I like about range percentage, as opposed to other metrics that try to evaluate shooting in the NBA, is that it is really just a measure of spatial shooting effectiveness. How much of this area are you going to average 1 point or more at? And what percentage you can flip that around, don't you do that? For somebody like Tyson Chandler, we would expect this number to be quite low. Who do we expect that number to be quite high for, and why? And the results I got for this are actually really great, in my opinion, because they validate all of these sort of intuitions we had about who were the best shooters in the NBA, which is something that no metric that I'm quite aware of has captured yet. So the names in your head, Ray Allen, Dirk Nowitzki, these are the right names. We want a metric that says, you know what, Dirk is one of the best 5 shooters in the league. Ray Allen's one of the best 5 shooters in the league. So that was what the goal was, and my results kind of validated that. And in fact, here are the top 10 in that metric over the last couple or 3 years. Steve Nash, number 1. That's the big take-home. That surprised me, may not surprise some of you who are big fans of his 90, 50, 40 accolades. I expected Ray Allen, and actually as a Boston guy, I sort of designed the study thinking, how can I get Ray Allen at the top of this list? I didn't quite get him there. I got him close. But Steve Nash, surprisingly to me, as I said, but maybe not surprisingly to many of you, has a 31.6 range percentage. So in the top 10, we're already down to 25.8. So there's only a handful of guys in the study of 200 or 300 players that actually are over a quarter of the scoring area, shooting an efficiency level of over 1 point per attempt. Some of these names may surprise some people in the room. I know, Hollinger, you're probably not surprised by any of this, so I was quite surprised by Rashard Lewis, too, I should say. But Steve Nash, that was surprising to me. And there's only 2 guys over 30%, and let's focus on the top 4. So when we map these individuals, we start to reveal spatial behaviors at a scale that I don't think I've seen many other places. And so this is Steve Nash's efficiency, and before you get sort of mesmerized by this rainbow of colors on the screen, I'd ask you to focus on the legend areas down here. There's 2 things going on. Number 1, I'm mapping the frequency of shot attempts by these proportional symbols. The larger squares indicate areas where Steve Nash has shot a lot. The smaller or invisible squares, no shots or very few shots. And then we have a sequential color scheme here that's mimicking sort of a temperature map on the Weather Channel. If you're a fan of Steve Nash, you want to see a lot of areas that are orange and yellow. If you have to defend Steve Nash, you want to see a lot of areas that are blue or green. So really critical patterns emerge right away. You've been looking at this for 4 seconds, and you already see things that you might not have known about Steve Nash's shooting tendencies. I'd obviously like to emphasize these areas where he's very effective from three-point land, but also draw your attention to areas where he's ineffective in the mid-range game. And this is obviously for a variety of reasons. Some of these shots are more defended than others. But what makes him great is that he has more of these orange and yellow squares on this graphic than anybody else. Tyson Chandler has a very small amount of orange and yellow squares. His squares are all orange and red, but there's only a few of them. Don't tell him I said that. Okay, Ray Allen, very different spatial signature. So another thesis, another takeaway from this paper is every player, every lineup, every team exhibits a unique spatial behavior. They put a different kind of stamp on the floor. And immediately when I look at Ray Allen, I'm drawn to the corner areas where he's one of the league's best shooters. And it's unsurprising to me that he is very, very hot from everywhere beyond the arc. But what is surprising is that he has a little bit of a weakness up here. And that's something I didn't know. And I'm sure if we played horse, he would make 100 in a row there. But in games, for whatever reason, he's less effective at that location. And when we look at Kobe, we see a different pattern altogether. We see a lot of action in this sort of north-south corridor. And the first thing you should see here is a lot of shots, guys. This guy shoots all the time. That's not news to anybody. But he's also shooting very well from many places. And we see a big corridor, this vertical corridor extending on his right side up this alley. And that's very effective areas for him, even stretching out to about 17 or 18 feet. He's making those shots at high efficiency. If I were to tell him where to work on his game, far be it from me, this baseline area on the left or right side, those are tough shots for him. And again, this could be happening for a variety of reasons. We're hiding that right now. This is all of his shots. So some players are good from some areas. Some players are better from other areas. We wanted to reveal those different spatial signatures. And the last player I'd like to focus on is NBA champion Dirk Nowitzki, who, if you look at Kobe, the area I pointed out as relatively inefficient for him, is where Dirk really makes hay. And this is one thing that makes Dirk Nowitzki a special player, is his ability to be really efficient and really effective from these areas where other guys were looking at. I'm going to go back to Kobe and to Ray and to Nash and ask you to look at this area. And it's really remarkable that Nowitzki is so good there when these other guys are not very good there. And there's a lot that the best thing about the research is it makes you want to ask more questions, right? And we have these for every player in the league. Those are the 4 I wanted to emphasize. How am I doing on time, Jay? Okay. So you can imagine a lot of utility comes when we start to make these comparisons between players or between lineups. I want to emphasize one thing. This study at the Sloan Conference focuses on individuals, but we can also do this for offense and defensive teams. So we can look at where points are being given up at abnormally high or low rates for defense. But they become extra sort of potent graphics when you look at them together with each other. And again, these are the 4 best shooters in the league according to my study, so there are going to be a lot of orange and red spots. But where those orange and red spots are quite different. For instance, Steve Nash at the point guard position doesn't find himself shooting a lot of corner threes, whereas Ray Allen at the 2 often sees himself shooting a lot there. And he should shoot there. He's very effective there. The exact opposite is true up here, where Steve Nash is really effective and Ray Allen has that little sort of, I hesitate to say weak spot for Ray Allen as a three-point shooter, but if he had one, this would be the one I would say he had. And similarly with Kobe, we can start to compare him with other players. So I think this is really important for a few reasons, and there's countless uses for this, really. Obviously, for entertainment, it's fine. But if you want to create a scouting report or print out a piece of paper for a coach and circle 3 areas that say, okay, here's where this guy coming in tonight is really effective or ineffective. One of the interesting things I found was Josh Smith, hilariously ineffective from the corners, but that did not stop him from shooting there. And I'm sure there's a famous study where if somebody intervened and said, Josh, you got to stop shooting, you're killing us, and he actually stopped for a game or 2, but then he went back to it. Now, but so it's not just these guys. So there's 400 guys I have these charts for, and when you compare the differences, you start to understand the nature, the spatiality of NBA performance in new ways. While I have you here thinking about this range metric, to show you the distribution of other notables. This is like on the golf tournament where they have the other notable players. These are not the second best 10. These are other players I thought were really interesting. Chris Paul just out of the top 10. Really good for a point guard to be that high. But his countless comparative guy is right behind him. Meanwhile, as a Boston guy, we know that Rondo, not accused of being the best point guard shooter in the league, and it actually performs worse than Tim Duncan with this particular metric, to give you an idea of how diverse his effectiveness is. The average guy in the league, 17.2% of the court he's effective at. All right, so we can start to do, I did positions too, so we can do plus minus versus a replacement player spatially. We can start to answer a bunch of questions about, okay, where is Durant good? And Durant's a great example because he's young and he's only getting better, but we can target areas where he should work on getting more shots or developing better shots in the offseason. And I'd like to place special emphasis on the bottom of the right side of this chart. There's our league leader in field goal percentage, who has an abnormally high field goal percentage this year. I think it's near 70%. Only effective at 4% of the scoring area. Not surprising. Chandler's a great defensive player and a great rebounder. He's not going to drop back and shoot 18-foot jump shots. So that's what we're seeing there. So this metric does a better job at sort of differentiating who I would characterize as pure shooting guys from guys who might be really effective. Dwight Howard as well, really effective near the basket. So the findings of the case study in general, okay, I'll wrap it up here in a second, is that I believe this is a good metric because it validates some of our intuition. It might not be perfect, and we're still going to tweak it a little bit, but it separates these kind of guys from these kind of guys. But the point I want to make here, guys, is this paper is less about finding out who the best shooter in the NBA is and more about looking at NBA performance through a spatial and visual lens and creating these new interfaces to these rapidly growing haystacks of data. And one of my main arguments is that we need new extraction techniques for these little tiny needles in these ever-growing haystacks of data. And I think spatial and visual analytics provide those, okay? So my overall conclusions are, yeah, space matters. We all know that. Why haven't we been looking at this? And maybe some teams are. I'm sure they are. And when it comes to space, conventional approaches are inadequate. Dealing with the big monolithic space of the court is unwise if your goal is to reveal spatial performance differences. New data, spatial data, optical data, these are really exciting to me, and I think they're giving other people headaches. But we need new tools to extract those needles out of these huge haystacks of data. And lastly, the translational research part of my project, which I just touched upon, make your analytics accessible to broad audiences. How do you do that? This is a whole field of scientific study looking at how you convert knowledge and communicate knowledge to people, whether they're the population under study or other people in the field. Make these things digestible. So the last slide here, what am I doing in the future? I'm trying to do some stuff with optical data. I want to work on defense, which I think is the big low-hanging fruit of something that really spatial and visual analytics can help us explain better than anything else has to this point. And looking obviously beyond shots at offensive events such as, or other events such as steals, rebounds, fouls, turnovers. They all have their own unique spatial signature, and I want to sort of reveal those and get people to understand how that happens. And then the last thing, if I have Steve Nash's shot chart and Orlando Magic's defensive chart for their starting lineup, maybe we can start to think about where certain sets should be run, where certain balls should be passed, and so forth. So that's all I have. If you want to get in touch with me, you can find me there. Thanks a lot. I'll take questions. Thanks. I have to remind you at this stage that we do have a microphone or a team of microphone-wielding personnel who can, if you have a question, please make sure you have a microphone in front of your mouth before you ask it.
You said steals, rebounds, fouls, turnovers are kind of the next frontier for what you're looking at the spatial analysis. I'm familiar with spatial analysis from soccer, where they look at it a lot because since there aren't as many scoring outcomes,
Yeah.
they look a lot at things like passes because they've got a lot of space. Do you think something like assists would be useful in this, or not so much?
Of course, yeah, that was a short list. If you read the paper, there's an assist example I use in the paper. But yeah, I think one of the things, I went to the basketball analytics panel earlier, and one of the more interesting things was who's passing to who, where are they passing to them, and when, and yeah, sort of, these kind of minute events have a spatial signature and can teach us a lot too. So soccer, I love working with basketball because these guys shoot 50, 60 times a game, and the soccer guys shoot like 4 or 5 times a game sometimes. So that's really helpful. But I think the soccer analytics community is a little bit ahead of us in thinking about just pass to pass, player to player, what's going on in this field space and how we can understand that.
Thank you.
Thanks.
There were a couple of range percentages that were kind of surprising. Like you said, Rashard Lewis. What is it about this stat that's showing us the stuff that we can't see with our own eyes that's actually making it that surprising?
Well, your own eyes are deceptive, and they come in with preconceived notions. And the good thing about computers is they don't have those kinds of notions. And I would have thought, just like David Aldridge, that Ray Allen would have come up on top with this metric. So for me, everybody has their own answer to that question of what it's showing that they didn't think it would show. But my answer is that certain players who maybe aren't thought of as great shooters are exposed as great shooters in this lens. Similarly, people who many people think are great shooters who happen to be in the three-point contest every once in a while are not actually really effective from as many places as we may be led to believe. Thanks. One more question. Okay, thanks.
Sorry. You said that you were maybe not convinced about the metric that you came up with as the range percentage. Was that a joke about hoping Ray Allen would be number one, or is there something complicated that you could maybe go into that wasn't in the presentation?
Oh, that's a great question. Thank you for asking it. I'll answer this and then get out of here. But there's a couple sort of, I won't say arbitrary thresholds in this metric, 1 point per attempt being one of them, and the size of the resolution of the grid that I'm using to model the spatial behavior on. These are not arbitrary decisions, and they influence the results. So I've been toying with different grid resolutions, actually irregular shapes on the court. Some people have actually suggested different sectors of the court that I focus on, or not dividing up the court into squares, but into pizza slice shapes and bizarre configurations. And I run. The good news is Steve Nash, Ray Allen, Dirk Nowitzki are always going to rise up in those metrics. But the 1 point per attempt, 33.3% from three-point land, especially. I don't know if that's good. So I try to be my own harshest critic on my research and kind of push it forward in new ways. But those are the two things that I think I'm skeptical about. And I'd like to talk to people from the league and actually answer the questions they're asking, as opposed to answering random questions that come into my head. So I think they would be really informative when it comes to those really important thresholds that affect the results. Thanks. All right. Thank you, guys.